Throughout this series of workshops, we're going to be using a tool called Tinkercad by Autodesk. Tinkercad is a free cloud-based simulation for both 3D modeling and for what we're going to be using, circuit design using all kinds of electronic components, including the Arduino. Tinkercad itself is free to sign up for, and if you already have an Autodesk account from something like Fusion 360 or Inventor or Revit that you might have used in one of your programs, you already have an account to sign in with. I already do, so I'm going to sign in with my Autodesk account, and that will take us directly once I've signed in with my Autodesk account, it'll take me to this landing screen or your dashboard. We're going to be working almost entirely within the circuits area. So if you click on circuits over here on the right, you'll pull up a copy of all of the circuits you've made. And you'll see there's all kinds of options in here, from simple batteries to a whole bunch of Arduino projects to some more weird ones like potatoes and lemon circuits. If you haven't created any circuits before, you'll see a totally blank screen. And to get started, we're going to go ahead and click on Create a New Circuit. If at any time you want to go back, all you have to do is click up here on the Tinkercad logo, and it'll take you right back to the dashboard. If you want to go back into the circuit you were working on, just click on it in the screen, click on Tinker This, and it'll bring you right back in. This screen has a whole bunch of different options, and we're going to go through a number of those throughout this and the next workshops in this series. The first thing I want to draw your attention to is up here in the top left. You'll see that it's given it a really weird, randomly generated name. Tinkercad is nice in that it automatically saves everything you do. And it auto-saves all of your projects as well. The first thing it does is give it a name. Now, I don't like these randomly generated names. They don't really mean much. But if we want to change this to something more meaningful, all we have to do is click here in the name and start typing. We're going to call this one my first project. Now, any changes we make will be saved under the My First Project name. We're going to work with a bunch of components in this series, and I'm going to introduce them to you as we go. The very first thing that we're going to need for all of our electronic projects is something called a breadboard. Over here down on the right, a breadboard, if I click and drag that in, a breadboard is a fantastic piece of equipment that allows us to plug in all kinds of different components and make use of some internal wiring connections. If you look closely at this one, you'll notice here along the top and the bottom side, I have what are called power rails. I have a negative and a positive. And if I hover over, as you see me doing, any of these dots or pin connectors here, you'll see a series of green lights that appear, or green circles. These green lights are all connected internally, so everything along this line is connected. Everything along this line is connected. The same is true down at the bottom. All the negative are connected, and all the positive are connected. In the rest of the board, you'll notice that there are rows that have numbers from 1 all the way down to 30. If you hover over any of them, you'll see there are some connections inside as well. For example, everything in 4 here is connected. It's not connected across this break, though. Down here at the bottom, you'll see these are all connected to each other, but they don't connect across the middle. That's going to be really useful when we get into more complex circuits. The important thing to remember now, though, is that we have connections going vertically inside here and horizontally across the power rails. Now we can start dragging in some components. We're going to work a lot with LEDs in this series, or light emitting diodes, being these lights over here. LEDs are fantastic in that they are very low power, but decently bright. So you can plug in a lot of LEDs and power them just off what's available inside the Arduino's power itself. Let's go ahead and drag in our very first LED. You'll notice that as I line it up on the breadboard, it automatically pops in to some connectors. So you'll notice it's automatically lining itself up within the rows. There's something very important to know about LEDs, and that's that they only let current through in one direction. Unlike a regular light bulb, if you wire them up backwards, you won't have any internal connection whatsoever. There'll be no light, no power going through this. Now, conveniently in Tinkercad, it tells us which side is the positive and which side is the negative. if you know how to read them. For example, the cathode here. The cathode is always the negative side. The anode over here is always going to be positive. So if we connect the cathode to the negative side of the battery and the anode to the positive side of the battery, this will light up. Now, we're not going to connect it directly to a power source. We're going to do all of our power through the breadboard. Another important thing to know about an LED is that they are very sensitive components. It's very easy to fry an LED. So anytime we use an LED in a circuit, we have to hook it up with a resistor. A resistor located right next to the LED in the top option. You always need these two together. If I want to plug in a resistor or use a resistor, all I have to do is just click on it and drag it into my board. Now you'll notice as I drag and hover that it tells me when it's connected to the negative rail. I have a connection here on the negative, I have a connection here on the top. I am hooking this LED up to the cathode, being the negative side of the LED, and the negative power rail. By default, LEDs in the Arduino simulator in Tinkercad are always 1000 ohms. They are significantly more resistant or higher resistance than we need them to be. But we can easily change them. You'll notice over here I have a box that says resistor, and I have an option for resistance, which I can set to whatever I want. I don't want it to be 1 kilo ohm. We're going to use a 220. I'm going to change this from kilo ohms to ohms, the Greek omega here. So 220 ohm resistor is what I want to use. You'll notice that the resistor changed, and these colors, to those of you who know how to read them, actually tell you the value of the resistors. The next thing I'm going to need, obviously, because we're doing an Arduino, is an Arduino project, is an Arduino. So let's grab one of those, and we'll drag it in just underneath the Arduino. The last thing I'm going to show you is one of the most common things you're going to use within Tinkercad, and that's how to make wires. So we've connected this just by dropping it into the breadboard, but we can also make wires to go to different places. And that's a really easy process. All I have to do is click where I want to start the wire, and then click again where I want to end the wire. And now I have a wire going from the ground, or the negative on the Arduino, into the negative power rail on my breadboard. By convention in electronics, negative wires are black. So I can easily change the color of my wire by just clicking on where it says green. You'll see a drop down that appears and picking black as an option. Now, on my screen capture, you don't see the menu that appears, but if you click on the word green, you'll see a screen that drops down and pick the color black. Also, if you don't want this to be a straight wire, by double clicking anywhere along the wire, you can create a bend point, which you can then drag and make a nice straight wire. So I've got my ground going into the negative. The last thing I'm going to do is take a wire from somewhere along the anode. I like to go near the bottom, and I'm going to connect it into pin 11 in the Arduino. Now again, I want to bend this, so I'm going to double click somewhere along the wire, create that bend point, and drag it out so that it's not overlapping. I like to make my wires correspond to the color of the lights. So I'm going to take this green wire, and I'm going to change it to red. So if you've done this properly, you should now have an LED, a 220 ohm resistor that connects from the cathode side into the negative power rail, a wire from the negative power rail into the ground on the Arduino, and then from pin 11 on the Arduino going up to line up with the anode side of the LED. If you've made it this far, you have completed all of the electronics for our very first Arduino project. Now we can jump into the code, and this is really where the Arduino shines. We can do a lot within the coding environment on the Arduino. By default, when you click on the code option here, or the code menu, it'll bring up this weird blocks option. I don't like this. I find this way too restrictive. So we're going to get out of blocks, and I'm going to click on here. I'm going to select text. You probably can't see the drop down on this screen. I'm going to select text, and it's going to ask me if I'm sure I want to go to text, and I am. So click on continue. We'll get rid of the blocks. And now you'll see that there's some code already preloaded onto the Arduino. We have two blocks in this code. They're called functions in programming language. Our first block is the setup function, and our second block here is the loop function. The setup function contains all of the instructions the Arduino needs to initialize and allow our program to run. This only runs once at the very beginning. The loop function contains the instructions we want the Arduino to carry out. Now, we could have things in here like blink a light or drive a motor, or we could get more complex instructions that you might see in a robot project or some of the things we're going to do later on. But this loop function, importantly, runs over and over and over again until either the power runs out or we tell it to stop. So this code that's already in here right now is going to do something within the Arduino. I'm going to run the code and then we'll break down what's happening. So if I want to see the code playing, I click on Start Simulation up here. And you'll see that on the Arduino, this L LED is blinking. Now, what's happening here? Well, in our code, let's look at the loop function. We are sending a signal to a light to turn on, telling it to wait a bit, and then telling it to turn off. And that's happening in the code. So this digital write here, in these kinds of pins along the top of the Arduino, this top row here, these are all digital pins. They can only do one of two things. They can send a signal, and the way the Arduino expresses it here is write, or they can receive a signal. We'll get into reading later on in Module 3. So digital write, in this case, means on the digital pin. By the way, pin 13 is connected internally to this light, so anything happening on pin 13 is also happening down here. So on pin 13, write high. Digital signals, unlike analog, can only have one of two values. They can only be a 1 or a 0. They can only be an on or an off. There's no in between in basic digital logic. High, in this case, means on. So our very first instruction here is take pin 13, remember that's connected internally, and send the signal on. The next line, delay. Delay means wait, very similar, and you can actually see this in the comments next to it. Wait for 1,000 milliseconds, or 1 second. Then, digital write again, send a signal to pin 13, the same pin, but this time low, off. Turn it on, wait a second, turn it off, wait a second. And we can actually see that run in the code here. So it goes on for a second, off for a second, on for a second, off for a second. And that's going to run over and over and over again until we tell it to stop. By the way, if you ever want to make any changes in the code, you must stop the simulation first. If you're trying to change and nothing's happening, your simulation may still be running. We can actually take this code that's pre-built into it, and we can use this to our advantage to make the light we just plugged in blink as well. There's a couple of ways we can do this. One of them is just to change 13 to 11, which is the pin we've used, but that's really bad coding practice. Generally, if you want to use something more than once in code, it makes sense to create something called a variable which holds some information for us that we can call to do a same function over and over again. So rather than saying, turn pin 13 on, turn pin 13 off, we can give that pin a name. And we're going to call it, for our purposes, the LED pin. We have one pin connected to an LED. At the very beginning of our code, before even the setup block, we can declare or create that variable that we're going to use throughout the code. Now, JavaScript, if you've done any kind of web programming before, doesn't require you to name the kind of variable. Arduino, like C and like a bunch of other languages, does in fact require you to say what kind of variable you want to use. So the variable we're going to use is something called an integer. An integer is a whole number between minus 25,600 and plus 25,600, or something like that, a much, much bigger range than we need to use. But that is the kind of variable we're going to use here. So we're going to create an integer, and we do that by writing int, the first three letters. The name of our variable, like I said before, we're going to call this LED pin. And then the value we want it to hold. Well, our LED pin is connected here to pin 11. So LED pin is equal to 11. at the end of every line of code we write, we need a semicolon. This is how the Arduino knows that this line is done and tells it when to start the next one. So what we've done here at the top is we've said, when I call LED pin, what I really mean is pin 11. What is really important about doing this or declaring a variable at the top is if I were to rewire this and change my LED pin down to pin 2, all we'd have to do is change the value once at the top, and it'll automatically adjust the rest of the code for me. The next thing we need to do is tell it that our pin 11, our LED pin, is an output pin. So it's a pin that's going to send a signal, not receive it. We can just change 13 to LED pin. And we can do that every time we see 13. So in this code, we're going to change it from 13 to LED pin. Now if we run our code, this light should be blinking in that same on for a second, off for a second. Now what if we wanted to make it blink faster? Well, all we have to do is change the delay. So if I change this from 500 seconds or 1,000 milliseconds to 500 milliseconds, you'll notice it blinks twice as fast. The last thing I'm going to show you in this very basic program is how to create comments. And you already see that here. This comment, this is not read by the Arduino. This is for a human programmer reading through the code. There's two kinds of comments we can make. The first one is a single line comment, which looks like this. 2 forward slashes on my keyboard, that is underneath the question mark key. And then a rough description of what it does. So I'm going to say turn the LED on. And then down here, I'm going to write another comment, / turn the LED off. So now if I get lost and I want to come back to my code, I know that this line turns the LED on. This delays. It's no longer 1,000 milliseconds. We've changed it to 500. So wait for 500 milliseconds, turn the LED off. That's one kind of comment. The other kind of comment is a multi-line comment. And let's say we didn't want this whole block of code to run anymore. Instead of deleting it, we can create a multi-line comment. The syntax for that is /*. On my keyboard, that is Shift 8. When we want to end that long comment, */. So now none of this code is going to run. This gets really useful if you have a big program and you want to take out a block or a single part of your code rather than deleting it and going back. Now if I run this, nothing will happen because nothing in my loop block is running. Okay, we've plugged in one single colored light. It's not the most exciting project, but it does give us the basis to start working with another component which can do some more interesting things. So let's leave the code for now. We'll click back on code, that'll send it away, and we can bring in more components. We're going to work now with an LED RGB, or RGB LED. RGB stands for red, green, and blue. And what that is an LED, or a light-emitting diode, that has 3 different colors inside it, a red, a green, and a blue. We're going to drag one of these in to our breadboard, and we'll have a look at the pins. So the second one here is the cathode, or this is the negative as we used before. And you'll notice the 3 other pins are labeled red, blue, and green. And by sending a signal to one of those pins, we can light up that internal connection. I'm going to drag this over a little bit closer because I want to use some pins down here for it. So as usual, because we have an LED, we need a resistor. I'm going to grab a resistor, I'm going to drag it in along the cathode side into the negative rail, and just like the last one, I'm going to change this to be 220 ohms. So this resistor is now 220 ohms in the cathode side. Unlike the last one, I can't just connect one light, I have to plug in all 3 of them. I'm going to use pins 5, 6, and 7 in the Arduino. I'm going to connect the red to pin 7 and make this a red wire. The blue, I'm going to connect to pin 6 and make it a blue wire. And finally the green, I'm going to connect to pin 5 and I'm going to leave this one green. I'm also going to bend these wires a little bit better. So double click, create a bend point, and then drag them to a different position. You don't have to do this, just makes it a little bit neater. So I now have my red pin going into pin 7, my blue pin going into pin 6, and my green pin going into pin 5. Let's go back into our code now and modify what we've already built to allow us to light up all of the other colors inside this. The first thing we're going to do is we're going to create some new variables, and we're going to make one for each of those pins. So, int, they're all going to be integers. Red LED, you know what, let's call it red pin, just to avoid confusion, is pin 7. Now, if you connected this differently and you plugged them into pin 6, 7, and 8, or 7, 8, and 9, you can follow along, but just make sure you change this number to be correct. I'm going to declare my blue pin. You'll notice as I'm writing variables that I've capitalized the word pin. And the reason I'm doing it this way is that if I were to put a space in my variable name, it wouldn't understand that this is all together. It sees the space and stops reading. So to make it easier for a human to understand that this is 2 words, I've done something called Camel Casing. And in Camel Casing, you capitalize the first letter of each new word, but keep everything stuck together. And if you've ever seen the sign for the makerspace at Algonquin College, we have camel cased the makerspace. So it's all one word, but the M and the S are capital letters. That was done on purpose because it is a coding practice. Now my blue pin is connected to pin 6. Remember the semicolon after every line. And finally, my green pin is connected to pin 5. What's nice about having done it this way is if I want to turn on the red light, all I have to do now, just like before, is call red pin. But before I can do that, I have to make them all into output pins in my setup. So pin mode, fairly self-explanatory. The mode of the pin, what it does. Red pin, comma, output. Importantly, output is all in capital letters. I'll do the same thing for the other 2. Pin mode, blue pin, also an output pin. And finally, because I'm lazy, Control C to copy, Control V to paste, Command on a Mac if you have one of those. So my red pin is output, my blue pin is output, and my green pin is an output. I've initialized or set up all of my pins with their correct mode. Now I can take this code we wrote before. I'm going to copy the code out of the brackets. So Control C, I'm going to paste it down. And I can modify this to turn on the colors I want. So instead of LED pin, we're going to target red pin. So the same code here, this will turn on the red light, wait half a second, turn it off, and then wait half a second. Because I've commented this chunk out, this is not going to run. It should only blink the red in this one. Now there's a mistake in my code. All right, so what has happened is that I've misspelt green pin. If you don't spell it exactly the same way, it doesn't know it's the same variable. I forgot one of the E's. If I fix that, now my red light blinks. We can use exactly that same kind of code to make the other 2 blink. I'm going to copy this. I'm going to paste it twice. So I'm going to have the red blink. I'm going to have the blue blink. Remember, we have to change it for both the on and off, the high and the low. And then finally the green. So now if I run this, what I expect I'm going to see is my red's going to light up, then it's going to light up blue, then it's going to light up green. Red, blue, and green. So we're cycling through all 3 of the built-in colors. What's really nice about RGB LEDs is that we can not only turn on red, green, and blue, but we can also combine them to get different colors. If I do, for example, the red and the green, so if I write them at the same time, they'll turn on at the same time. Digital write, green pin, high. Remember that semicolon at the end of the line. going to copy this again, Control C or Command C, Control V or Command V to paste, and send that to low. So if I've combined red and green, just to make it absolutely clear, I'm going to write a comment block for all of this. So / star, 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 /. So now I'm only combining the two. So if I combine red and green at the same time, I get yellow. Let's try all the other colors. So that's red and green. Let's see what happens when I combine red and blue. So I'm going to get yellow first, and then magenta. And then the final combination of two colors will do green and blue together. So green and blue together. I now have yellow, magenta, and cyan, which, if you've done any kind of printing, are the three primary colors of ink. So the three primary colors of light are red, blue, and green. The three primary colors of ink in printing are cyan, magenta, and yellow. If I uncomment this, it will cycle through red, blue, green, yellow, magenta, cyan. There's a seventh color we can make with this, and we can get that by turning on all three of these lights together. So I'm going to add to this digital write red pin high, and same thing down here. Red pin low. So by having all three turn on, I should cycle through red, blue, green, yellow, magenta, cyan, and finally white. White is a combination of all three of those. So using this one component, this one RGB LED, I can create 7 different colors. Now, for our purposes, let's complete this by turning on that first light again. So now we'll have this light blink, then we'll go in through our colors. We've now completed your very first Arduino project. Let's recap what we covered. We learned a bunch of different things in this session. One of the first things we learned was some basic electronics. We looked at LEDs, or light-emitting diodes. We looked at resistors and how you always need to have a resistor with them. We also looked at how the breadboard is connected internally. So I can recap. These pins are all connected inside. The power lines, or the power rails, the negative and the positive, are all connected internally. We looked at the Arduino and how different pins connect, the ground being the negative, and how we can use all of our digital pins to send a signal out, or to light, in this case, light up our LEDs. From a code standpoint, we learned about variables, which are words or placeholders that we can assign a lot of different values to. We looked at the different blocks, the functions, the setup function, and the loop function, and we'll get more into code as we go. We explored outputting, or writing. So digital write, sending a signal out on the pin to turn something on or turn it off. We looked at delays, or pauses. We looked at how we can combine various lines of code together to make things happen simultaneously, or use a pause to put some space in between them. We explored in the RGB LED how we can, using a variable, target the red, the blue, and the green. We also looked at some building of some sequences. We learned the 2 kinds of comments, the single line comment and the multi-line comments. So in this first session, you've covered a lot of the most important elements of code and the beginnings of some electronics. In the next session, we're going to start looking at loops and how we can make different parts of code run over and over again. I'm now going to show you a few more parts of Tinkercad and how it can be really useful from a learning perspective. So now that this project is done, let's come out of here and go back to our dashboard by clicking on the Tinkercad logo. In circuits, you'll see my first project should be the very first one, in your case, probably the only one that appears. If you have a real Arduino kit and you want to take what we did in this virtual simulator and turn it into a real project, there's actually a built-in way to do that. So if I click on the project, and I click down here on Simulate, it takes a little while to load, but you'll see a screen that has our project on it. Now here, if I click on Start Simulation, I can see it running just to find out what it does. But if I want to build this into a real project and I want to see which parts I specifically need, over here on the right, you have what looks like an Excel spreadsheet. This will give you a full components list of everything you need. So I have one red LED. I have two 220 ohm resistors. I have an Arduino Uno. The Arduino model itself doesn't really matter. And I have an LED RGB. These are all the components I've used in this circuit. This was a fairly simple circuit, so the parts list is fairly restrained. But if I had, I'm going to back out of this. If I have a more complex project, and I've built a few of those, let's say we look at something like this, which has many LEDs and many resistors, I can pull a parts list using exactly the same thing. Find out exactly how I need. I need 8 yellow LEDs, 8 orange LEDs, 8 red LEDs, 8 resistors to build this sweep scanner. And we'll get into more complex projects like this later on. Another thing I'm going to show you is if you want to take a project we worked on now, you'll notice the one next to it is called Copy of Arduino 1. If I want to duplicate it so I can modify it without breaking the original, if you click on the gear, you'll have something that says Duplicate that appears. And by duplicating, it'll automatically create a new copy that I can go in and work with. If you want to modify what we did today, I would highly recommend you duplicate it and play around with the duplicate. And the final thing that I'm going to show you, if you go to somebody's profile, for example, I'll go to mine, and you want to see some of the projects that they've worked on and maybe copy your own. I've only ever made some circuits, so if you click on circuits, you can see all of the projects that I've made public. And there's a whole bunch of these that are in here. If, for example, you want to copy the project for the next series that we're working on, which is project 2, if you click on the project, you'll see a button here that says Copy and Tinker. If I click on this, it'll copy that project into a working area that I can then modify. This project is also saved in your own profile. So when you go back to your dashboard, you'll see the projects that you copied. I have made all of the projects from the first few workshops in this series public. So if you follow the link that I'm going to put down in the description to my profile, you can actually go and work on the project we just did, see my finished version. That way, if anything in your code doesn't work or you want to see how I did it, you can go copy and tinker my project and make your own modifications to it. That sums up all of the basic parts of Tinkercad as a simulation environment. Like we said before, we've done some basic electronics, we've done some basic code, and in the next 3 parts of this series, we'll take you from this very basic project we did today up into something that involves user interaction and user control. I hope to have you with us for the next 3 workshops in this series, and thank you for joining me for Arduino Part 1.